Chapter 6, Section 5, Solving Proportions. Now, proportions, as you will see, is basically when we have two fractions equal to each other. Now, there would be a variable in there too, but just a proportion is two fractions set equal to each other. Now, when setting up a proportion, we'll be comparing two units. Could be meters to seconds, degrees to days, etc. So, to set these up, we'll want to write the units we're dealing with as a ratio. And remember, ratio just means fraction. So we'll work on it down here, but that's what I'm talking about, like miles to minutes. So we set it up as a fraction. So let's say we just traveled 40 miles in 30 minutes. This is likely by car. At that rate, or at that speed, how many miles can you travel in 45 minutes? So right now we're looking at a rate that's comparing miles and minutes. So specifically for this, our ratio will be 40 miles over 30 minutes. Now this next part is just a general thing that's helpful when you're trying to problem solve. And I mean that more than just in math as well. We want to look at the information we have, identify what we do have, and what we're trying to find. So we know that in 30 minutes we traveled 40 miles. We also know that we're wanting to see how far we travel in 45 minutes. So 45 minutes is a known amount of time. What's unknown, what we're trying to find, is the distance we travel in 45 minutes. So we're going to set up a proportion. And the real reason we even bother writing this miles over minutes is I just want to emphasize that it doesn't really matter when you're setting up a proportion what you put on top or the bottom of the fraction as far as solving it getting it correct. But once you decide to put miles on top, it's got to go on top for every fraction. If you decide minutes go on the bottom, it's got to go on the bottom for every fraction. So we already set the first one up. So 40 miles over 30 minutes. And we don't know how many miles we're going to go in 45 minutes. So 40 miles in 30 minutes. And we want to know how many miles will we be going in 45 minutes. So this is miles. This is minutes. And I'm not going to require you to write the units every time. I'm just trying to illustrate right now how we do have to be consistent. We put miles on top everywhere, minutes on the bottom everywhere. And the good news is, to solve a proportion, it's just two steps. First, you cross multiply. And we say cross multiply, we actually mean multiply diagonally. So I'll go ahead and do that step for this one. So I do 30 times m equals 40 times 45. And 40 times 45 is 1800. So that's our first step. We cross multiply, meaning we multiply, well, it makes like an X. I don't know why they call it cross multiply, but that's what all the mathematicians call it. So you multiply diagonally, lower left times upper right, upper left times lower right. And your last step is to divide both sides by the coefficient. So it's just two steps you do every time. So we divide both sides by 30. We get m equals 60. Now plenty of these, you'll just be doing the math and the numbers and there won't be a word problem associated with it. But since this was drawn from that problem, I want to explain that what this means is since we can go 40 miles in 30 minutes, at that same rate, we would travel 60 miles in 45 minutes. So that's what a proportion allows us to do, is say, okay, if this is the rate we're going, what will be true at a different amount of time? This is our distance traveled in 30 minutes. This is our distance traveled in 45 minutes. So we'll follow those same steps on the back ones. These aren't word problems, they're just proportions we're solving. But you cross multiply. So x times 2 is 2x. Negative 3 times 6 is negative 18. Then we divide both sides by 2. We get x equals negative 9. Number 3, we cross multiply. T times 5 is 5t. 1 times 3 is 3. Then the goal is to get the t by itself. So we divide both sides by 5. Now that doesn't come out to a whole number. We can't do 3 divided by 5. So you're welcome to leave the answer as a fraction. Or if you type that in your calculator and get the decimal, that's fine too. Either one of those is equally good. Okay, number 4, we cross multiply. X times 4 is 4x. 3 times 12 is 36. Then we divide both sides by 4. And some people have asked me before, like, well, how do you know which one to do first and which one to do second? Technically in math, the ones that are on top keep their sides. So I did this one correct by putting at 4x on the left because x is on top on the left and 36 on the right because 3 is on the right. But there are problems you'll do later in your math life where it really does matter which one you put on which side. At this level, though, it doesn't. So I just tend to always put the variable on the left and the number on the right. But I mean, if you think about it, if I had done it backwards like this, the only difference is I'd be getting 9 equals x instead of x equals 9, but that means the same thing. So either way is fine. I just tend to put the variable on the left, so I do the variable part first and the number second. Okay, so 5, we cross multiply. B times 10 is 10b. 4 times 25 is 100. Then we divide both sides by 10. And we get b equals 10. Okay, now number 6, you won't see a lot of these, but you'll see a few. And I just wanted to challenge you with this one. So the overall process is still the same, but it will take a little bit longer. So we get y plus 3 times 8. Now the tricky part is you got to make sure you do 8 and in parentheses y plus 3. Because it's not just the y that's being multiplied by 8, it's this whole thing. 2 times 4 is 8. So to do this correctly, you have to distribute the 8. You can't just have 8y plus 3. You have to have 8y plus 24. So when there's a y plus 3 or there's a plus or a minus with the variable, you got to make sure you distribute whatever's being multiplied. So now I'll subtract 24 from both sides, get 8y equals negative 16. Then divide both sides by 8 and get y equals negative 2.